Yeah, there's a slight change in today's program. So Dr. Rajendran was supposed to make a presentation. He had got everything ready, but he was called yesterday and told that he had to join as the director of Institute for Climate Research in Kottayam today. So he is gone, so he cannot come here. But I'll present his PPT. And if there is any doubt, the students tell us that she is at university, so she will answer all the questions. Okay. Yeah. Okay. So Rajendran ran this CFS V2 version he has, which is not the same as one in IMD. That's why difference, both in the resolution and some details. Okay? He ran this in the good computer they have at CMAX or Fourth Paradigm Institute, and he gets a typical correlation skill with, I think, 3.4 was the order of 0.4 for February and May. Okay? And our is pretty large, but 3 millimeters per day. It's not very different from what IMD has. And so for this year, every year he does this, and he has made presentation the last few years. So this year he made 1, 2, 3, 4, 5 initial conditions, starting in late April and early May. Okay? So the 5 number and so on, not very large, but still good enough for us to understand how sensitive the results are to ensemble member. Okay. As a matter of fact, I didn't want to ask, is some way to get hold of data from IMD or IITM to compare with this, each ensemble member separately, so that we get more idea. Find out if they can give, so it will be good. This is a 5 member, it gives some interesting results, but 5 member is too small in my view. Okay. Now, first thing I want you to notice, which is surprising, he has given the climatology of IMD and the climatology he has made out of 10-year simulation, and it looks quite good. Okay, look-wise, it's pretty good. Okay, except I think you see a Gibbs oscillation here. All of you can see there's a problem with the orography always. That you can remove it if you want, but you have not removed it. So I would say that this and this are looking very good, but it is hiding something. It is hiding the fact that this simulation is much drier than this. That's not visible here, partly because it's a non-linear color block. Be careful. It's not 100, 100, then you go 300, 300, 300. Okay? So it doesn't quite break out, but I must point out that this simulation, the dry bias is less than in the IMD simulation. So somebody has to look at why there's so much difference. Because almost same model, somewhat higher resolution, and some minor changes in the maybe parameter information. But overall, spatial pattern, I'm impressed. It gets everything right here, and here, except for the Gibbs oscillation, it looks quite nice. Gets the northeast correctly. So I'm overall quite impressed, except for problems with Himalayas and its impact on this oscillation. And then I want you to highlight this. This is the IMD's climatology. This is the climatology of February. Okay, so it's almost 70 millimeters depth. Okay, I consider that to be a serious flaw in any model. I'm fundamentally, I believe that if your model doesn't get the mean rainfall correctly, anything else you do is not that important. Okay, I talk in the perspective of climate change, not field forecasting. In climate change, people have shown that if your mean climate is too cold or the mean climate is too dry, it has a huge impact on the perturbation you make. For example, global mean temperature. If your mean climate is too low, it shows a lot of global warming. So people have argued that you should select a model whose mean climate is too far from the observer because it will show a different impact of any perturbation. But seasonal forecast, I'm not so sure. But anyway, this problem is there in all models. We don't have any model which has the correct monsoon rainfall so far. If any of you have seen it, let me know. Okay, so these are the years simulated, 10 years, including the forecast of this year. And these are the numbers from this simulation. This is T382, okay? And this is the deviation of each year compared to the mean. This is the IMD's mean value, and this is the IMD's deviation, okay? Overall, I would say it's not bad. I would say that, for example, here, -6 is -10, with that plus or minus 4%, -6, -11, slightly beyond. This is way off, plus 9% here and plus 4%. This is wrong sign. This is a wrong sign. So these two years are quite bad. Signs are wrong. Okay. Here I would say rainfall too low compared to observed. That is, of course, 2020, we know something new will happen. This is quite good, 21. 22, I would say not bad, 4.5. And last year, it got too low rainfall compared to observed. Okay. So what is predicted this year? Plus 6.8%. So this is consistent with what we all discussed in the first presentation, all the models. Very similar, and I will talk later about Sumant Nigam's model, which we discuss normally. So that Rajendran gave it to me, so I'll discuss it later. That's also similar. Almost everybody is saying plus 6%. So that part is not very unusual. Okay, now here is the June, July, August anomaly. First is anomaly, and so according to this simulation, interestingly, Rajasthan will get well above normal. Maharashtra will have problem. Okay. Southern India, Western India will be above normal. And yeah, that's all close to normal. So this is the signature that is there. We'll see whether at the end of this season, whether this feature is seen or not. And later on, I'll compare with Nigam's result. Remember that Nigam's result is not a model simulation. He merely correlates SST patterns all around the world with rainfall. Okay, so this is in a way similar to what Rajendran showed some time back of June, July rainfall. He correlates with this is taken to in a higher level with UFs and so on. So use all the past data to construct the rainfall for the next season. Okay, so this approach, statistical approach, is I think has a value to me because past SST variation has some impact on future rainfall. So Nigam, remember last year was celebrating in the end of August because his simulation was very close, but September everything went wrong. So still that problem is not simple.
What's the mean?
Huh?
In the previous slide, it says 6.8%.
Plus 6.8, yeah.
Well,
But remember, this is with respect to its climatology, not this looks below normal, but that's because the model climatology is 790. Remember that. The model rainfall is mean is 790, it is 6.8, but above that. Everybody does that. Everybody compare their model with their model climatology because they are very different, unfortunately. Okay, now he has also compared overall anomaly, which of course is the opposite to rainfall, but notice that he has used a different color bar so that the colors look similar. Now negative is green here, positive red here, so it's very similar. Where rainfall is more, overall is less, where rainfall is less, overall is more, so very similar pattern. And being overall, of course, there is no fine structure, so everything is smooth and well, this also we can compare at the end of the season. Now here comes, which is not available from IMD or from Skynet or anyone, month by month. I like this because what I find is he is going to be right this month most probably. When I discussed last week's performance, you will see that the monsoon progress is stuck here. It's not moving. Okay? So this is where the discussion about Kerala onset versus Central India onset is what discussed. Cold monsoon onset. Because just because onset Kerala occurred on time, there is no guarantee that onset will occur correctly over cold monsoon zone. That's what is happening. I don't know what the reason is. Very simple. It's completely stuck here. You will see that. And when I make a presentation. So this looks very realistic so far. Only half the month is over. 15 days more that we'll see what will happen.
Yes,
Yes.
when the onset was declared,
Huh?
when the onset, Irish was onset man,
Ah.
it looked like the Bear branch had an earlier onset compared to the plant.
Yeah. But right now it's not there. It's not moving. I don't know. Somebody, is there any possibility that some low person or someone's farmers move and not moving? That's the reason. I don't know. So it's amazing that from Bay 50, and it has already reached, there is nothing happening in the Bay.
So if that onset has already happened over the northern part of the bay, shouldn't it bring rain to the
Yeah, I should the answer to that. I think that it is different progress in Bay You see. Yeah, sir. What is interesting about Rajendran Sumdar is the August. He's showing a very high positive in August. We'll see. He'll come out right. July is similar to seasonal mean that Rajasthan was the Maharashtra. And September, he is showing large deficit in Maharashtra, while all the other models we saw showed a high rainfall in September. So this is again a point to be looked at. Why this is showing this is not clear. Later on you will see I'll show 3.4 in this model. It does go down to large negative values. So why this pattern is not clear? So we will have to see the evolution, see why this happened. Now, here's the thing which I like and I would like to see 50.05 points. That the June there is no signal because two of the simulated say above, two say below, one say normal. To me, June there is no signal in the all India mean, but there's a nice signal in the spatial pattern. So that may be right, but the other thing may not. See, here it is saying we really don't know whether it's above, below, normal. But if you go and look at the progress till today, it is 20% below normal. Unless something dramatic happens in the next 15 days, which can happen, it's not impossible. June rainfall will be definitely 10% below normal. So the point is that this is saying normal. So 2 above, 2 below, 1 normal. Look at July, it's a little more complicated. There are 2 extreme lows here and 2 extreme high and 1. So to me, these 2 are similar. So there is no real, confidence about our forecasting. But look at August. August is very clear, it's only on one side. So his prediction of August over normal has only one sign. If he gets it right, I will say this model has something. If he gets it wrong, he got it totally wrong. Because all the information all in one direction. September again is like these. So to me, in the simulation so far, only August shows a clear indication in one direction. Others are showing that the conditions prevailing this year are such that the model is not confident enough to tell you that above or below. Okay. So this is the kind of thing I wanted from the 50-member simulation, because there will be more confidence in that. Because of 50 members, you can draw a distribution and have a look how much it deviates from the symmetry. Yeah.
Simulation starting from that date.
Those days, yeah. See, remember, it showed 5 days. Each of the 5 days, it is given below. Can you read it?
Yeah. So,
April, May. Yeah.
so May 11 should be the latest, the best activity.
Well, I don't know. See, I think this is the big debate I wish to somebody come and talk to us. See, you would think the latest instrument is the best, okay? Provided your initialization is good. If the initialization is not done well, it can take you some of the direction. So it's a question of your assimilation procedure and the kind of data you're able to assimilate. If they are very good, you are right. If the data from your satellite observation are all assimilated correctly, then you're right, the latest should be the best result. But suppose you have some problem, because I'll tell you why, there's a whole paper on this, from the IITM group and Rajendran group. IITM group claims February countries are better than me. I mean, I can't believe that. Okay, but they swear by it. You can go and read the paper. Rajendran got a different result, if I remember correctly, the other way, which to me makes more sense. But this is very sensitive to how good is the assimilation. I'm not clear about that. How do we decide that this particular day I get got all the data in and I have the best condition and this goes further, okay? This is further because this is a big issue from whatever you have seen, not about rainfall. I will show you later on, 3.4, that bothers me very much. So rainfall, we are still know, we are still aware that it's a tough variable to predict, okay? So I'm not blaming anyone, they get on the rainfall, right? It's tough. But SST, in my view, should be treated correctly. Because that's much more stable variable, which is less noise in it, more inertia in the system. But even that there's a problem in it. Yeah, so this is the same thing as shown the time series. That's also good. We don't get this from other sources. So this is the simulation, average over all the 5. And this is his normalized simulation. That is, this is the climatological daily rainfall. This is the actual rainfall this year. And this is the IMD. Okay. And you can see that this model in its climatological setting has 2 low rainfall in July. That's the weakness of the model. Same thing is true, I'm sure, about IMD people. But this year, this model is showing higher rainfall than IMD in August only. Rest of the time, except we'll see that, except near the end of June, beginning of July, next 2-3 weeks it shows high rainfall. But otherwise, most of July, this model is showing well below its own climatology and IMD. So this is interesting thing to look at, and we'll, when the season is over, I'll put this back and we'll see what can we learn. Now, this is the one I'm very interested in, 3.4, which I thought the model will show that all the initial conditions should show the same trend. Okay, look at one of these. I mean, I can't believe it. So I'll have to talk right, and then again I'll find out what would have gone wrong in this simulation. That it suddenly plunges to minus 2.5, while all the others are around 1.5 and 1.5. Okay. I would say this spread is okay, although it's also high. This spread is, but this is ridiculous. One thing going away. And for this to happen, the SST bothers me. I want Vinay to tell me, is there anything in the ocean model which would make it go that far away? Yes. Just because I told them the use condition. I don't understand the physics there. I told someone, let's see whether you're not, yeah, let me again focus on this and allow Rajendran to answer. This one is May, the latest. By the way, Shaka, the latest one. The latest one goes plunging like that. Okay. Now, I think we'll wait and see the actual. If the actual data follows this, then I will say Shankar is right.
May was a bit turbulent time, right? There were those big systems. Which came kind of the equator and other places.
Okay.
So that might have had an initial condition.
Okay.
Which is very good for
both good and bad. If it turns out that the actual 3.4, which will track over the season, follow this line, then what Vinay thought could be the point. Otherwise, it worries me that the essential prediction is so sensitive to this condition. Because you got the right SST on May 11th in the Pacific, right? You assimilated all the SST correctly. And within 3 to 4 months, you are showing a very different from the. So I don't understand. That is not clear. The next plot is about DMI. Unfortunately, for some reason, it got inverted. So I'm very sorry about that. It got this way. But I'm sure we can see that in the model DMI is very high, around 1 year, then goes to 0 by September. So this I don't know why. Okay. So any question on this? Any clarification you want?
Type of rainfall from the model.
Huh?
On the model, there's seasonal factor of rainfall,
Yeah.
daily values. So other than thinking that all the five members we show different peaks, but there's such a flat rainfall, there is no seasonal cycle at all. Because it's just from that.
See now here. This is owing the rainfall.
Yeah.
It's not said again. So that's interesting because we don't see that kind of data from others. So let's again look at it so that, yeah, this one, right?
Yeah.
Yeah.
It's very, it just possibly suggests that five rivers are peaking at different times.
Yeah, I think what we have to check, Rajendran, is what kind of interesting variability this model gets. Right? That within the season, you're saying variability is.
Yeah.
Yeah. So we have to say whether it has some realistic interesting variability in the season, within the season.
Another
Yeah.
point is that,
By the way, this is some red line, terminology, I have no problem. Because I always remember Indian monsoon is a very interesting feature. It is linearly increasing up to July 15, and then flat till August 15, then comes down. That is the climatology. So to me, climatology looks reasonable, although the numbers are up. But you know the shape. But sorry, according to IMD has an alternate 20 years. Yeah, IMD, I think, yeah, sorry, IMD goes higher, then comes down to here. Let's check this. This is only 20 average. I looked at a longer average. That looks very straight that down. Yeah, so anyway, later on, we plot the actual variability observed. Let's see whether there's any, what do you call, anything that is there which is completely wrong. Okay.
I have another point to,
Huh?
I have another point to add.
Huh?
That the rainfall pattern, right, the anomaly doesn't look like there's an ENSU signal. There are two reasons. First of all, ENSU signal has in the Maharashtra and western part of the highest rainfall signal. And La Nina does not give you a high rainfall there.
Yeah.
That's one point. Another point is that August, all the high rainfall he is getting is because of August rainfall. That's also just a sign that it is not because of because August doesn't have any ENSU signal. Very deep, it is September and possibly this one. So there is something is buzzing. That's what I'm thinking.
Okay, we'll see. But if you can get out of similar data from IMD stable people, that will not more.
Yeah.
You can get out of some data actually. Even climatology, even average of all, I have to look at all the, I would have to say all the 50 to see really what spread is there.
The simulation must be right. What I'm trying to say is that the reason may be something different. That's what I'm
Yeah. Okay, so that thing, I'll go to my presentation. So before I start the presentation, I want to say a few words about why was Rajendran selected for this post. I show you a reason for it, okay? So the interesting history behind it, which many of you who have been here recently don't know. Rajendran did his PhD here, I think around 2000, right? 2000, 2002, around that time. And then he went to a postdoc in Japan, right? To work for the Quito, the most well-known name in Japan, climate modeling. And he looked at the 20 kilometer resolution model, which is very high resolution for a climate model, which was integrated for 100 years. And what I was impressed at that time, this paper published in Current Science in 2008, you can download that the spatial pattern of rainfall over land in the model is very close to the observed, except Kashmir. Kashmir is always very different because it's closer to mid-latitude, but otherwise it's pretty close. I'm quite impressed because this, I remember, about 20 years ago, when all the more they have difficulty getting Indian monsoon right, this MRI model got it right. So it was very impressive. But the more impressive part about that work is the impact of climate change. The climate change impact projected is remarkable. This is the first ECM ever to show that rainfall will decline over Kerala. Okay. So very impressive result. The rest of India is going to increase. Now, why is that? The reason is very simple: orography. The rest of India is not driven, except for Himalaya. The rest of India is not driven the orography. So they are increasing water vapor, increasing the rainfall primarily, and circulation somewhat modifies it. But over Kerala, up to some point here, the rainfall is declining. Now, why is this interesting? It's interesting is because it is quite close to observation. In the last 50 years, rainfall has declined in Kerala, notwithstanding the flood in 1890. That is a separate small-scale variability. Over the trend you see is declining. Okay. Now, you don't hear much noise in Delhi about Kerala rainfall declining because it's very high. People don't think about it. But remember, for that ecosystem, it is dangerous. If that trend continues for another 50 years, Kerala, many agriculture will be in deep trouble. Because if this is a long-term trend, consistent with global warming, and why you will see, why is the reason in the paper that he published later is because the Somali just shifts slightly north, that's all. Remember that the rainfall in Kerala is primarily orographic. If the jet maxima shifts north, it will come down. Okay, it's as simple as that. Others have published results later on also showing that in the last 50 years, according to financial data, Somali has a decline. I think you'll agree with that. There's a slight decline in Somali, not very large, it's there. Decline. Okay.
Sir,
Yeah.
I think you also pointed out in last year monsoon cafe maybe that also over the northern Indo-Gangetic area, last 10 to 15 years there is a huge decline which has not got much attention because that's not a water deficit region.
Yeah.
But for I think 7-8 years of last 10 years is basically a drought almost close to 20% in that belt.
Where?
From that Indo-Gangetic.
Yeah, you're right. That area, we discussed the further this year also, because this area has shown drought for a long period. I don't like. And nobody has any simple explanation for that. I'm not seeing. And it's a serious matter because it's going on for a long period. So that's, as a matter of fact, that's one thing I find very surprising. See, a lot of discussion globally on Sahel rainfall. It's been declining for the last so many years. So you'll hear a presentation in this Monsoon coverage sometime. There's a decline from 60s to almost to 80s. Okay? Then it recovered. Okay? Huge discussion globally because a lot of countries are affected, a lot of drought, war, all kinds of consequences. About Bihar, Uttar Pradesh, there's no discussion. And how they survive because if rainfall goes up and down a couple of years, anybody can adjust. But it's a steady decline in rainfall for a long period, groundwater comes down. Although groundwater issue is not that serious in Indo-Gangetic plain. And how many we know, Indo-Gangetic plain has got a very thick layer of soil. Because India went to take the Chinese Asian plate, and there is a ditch there, huge ditch. And all the Himalayan debris flows in. So it's a very porous, and I'm told that people have done groundwater work, that the amount of water flowing below the ground is as high as above the ground. Okay. So they are actually that way that if you have the power, if you have the borewell, you can survive any drought. But to me, it's a long-term issue. We don't understand why there is a decline. You're right. Okay, so this to me was a very interesting result, and we know physically why it's happening, and only a model with 20 kilometers can produce it. We take a model 100 kilometers, it won't show you because there is no orography there almost. Okay. Yeah, this is a close-up, which I want you to appreciate. This is gauge data, 48 to 97 old, and this is the model, model future trend. This is the change between 10 years of the 21st century and the previous 50 years. Okay? So you can see that the pattern is similar, which I think is quite remarkable. I mean, I didn't expect that. It shows large decline near the coast and then some here, some increase, which is not seen here. This may be due to lack of data because you need lots of data here to get this kind of feature. Okay. So I would say that the model trend is showing due to CO2 increase is consistent with what's happening in Kerala for the last 50 years. Okay, now I plotted the zonal wind difference between the present 30 years and the previous 30 years, you can say clear up to the point where the model shows decline, the jet has declined, and then here it is slightly increased, not much. Same is happening over Burmese coast. So that's very interesting that the jet has shifted in both places. Okay? Although here it's much more impressive than dipole structure. So I think that I'm sure, I don't know if you do a moisture with only South India, you will see that clearly, the numbers here. Okay, now somebody, I forgot to note down reference. Somebody, I think it's Ajay Mohan, who is also a student here. He has shown that the axis of the jet is shifting now. That was a good result. So axis shifted up, that means instead of the big rainfall occurred in Kerala, it occurred in some other place closer to Mumbai. Okay. Now Mumbai, a little bit south, maybe that's a very somewhere. So this is also consistent with this.
The shift in the axis.
Ah,
It's more like a brake condition, right?
more than.
A brake condition during any particular monsoon.
No, that's actually what DJS.
Yeah, but if you do an announcing within the same season, whenever
Okay.
you have a brake, the axis shifts something.
The break down, not up.
Yeah, so between the two.
Yeah, see, I don't know how this year, you look at brakes in India, it just goes around India. That's what happened. But you remember that? I remember that it always shooting out.
Yeah, maybe you has always been talking about that when you have brake condition, the jet shifts some sort of.
Yeah, I think somebody can easily verify, they are not whether this, in brake, the jet shifts upward or downward. My impression is goes downward.
Yeah.
Here it's going upward. Okay.
Does that Kito model, that model,
Ah,
also capture the increase of rainfall in that Konkan region?
what the resolution?
20 kilometers.
Yeah, 20 no problem. All I'm saying is there are very few people running 20-kilometer resolution model in single 6. So somebody has to actually develop all the stuff. Which model has 20 kilometers? None of them. Okay. I think the best is 50 kilometers, right? 100. Huh? Yeah. So for me, the CMIP 6, all look at all the models, they're all 50 kilometer range.
No, I'm saying Rajendran's model that is not shown. That Kerala rainfall is decreasing. Just 3-4 slides back in shown that Rajendran model.
Which one are you talking about?
So Rajendran Kito, what Rajendran did in Japan.
Previous slide, please.
Huh?
Previous slide.
Okay.
First slide.
I didn't get that. Which one about? This one. Huh? No. Which one got red?
India.
Huh?
One for the video was.
Oh, previous one. This one you're talking about. What's the problem? Yeah, so what is, this is Rajendran. Yeah.
Yeah, I was just saying that the decrease of Kerala also whether the increase in the Konkan region that is supposed to be because of the shift of the jet, whether that is captured. So it's like it's captured.
Yeah. I mean, my claim is that this increase is because they shifted here, okay? But that is verified. This is only a hypothesis. Somebody has to look much better to show that really it went up.
Yeah, but then that theory, it should also explain why there is a kind of countrywide increase, right?
Then what?
Countrywide increase in rainfall. Kerala has less rainfall. Rainfall is decreasing.
Yeah.
But everywhere else it is increasing.
Yeah, so everywhere increasing, simple logic is 1 degree increase. See, with 1 degree forming in the last 100 years, 1 degree goes up is 1%. That's what I want. So if the it doesn't change, that is big if, then you can start to increase in rainfall. That I don't get quite possible, right? But what Kerala, the things will goes down, you whatever goes up. Question, how much is the entry gone down? You're right, you have to. I think about doing that just to check those small blocks over Kerala, And anyway, not much water going on. So if the flux, how much contribution of increase in water vapor and how much is contribution of decrease went up that. But look at it, I will not get that detail because I don't trust the analysis next week. Okay, I get I remember TV Joseph 20 years ago. 20 years ago, Joseph, the old guy, with limited analysis data, 20, 30 years ago, he published paper saying someone got a leakage. I said, you look at NSAP and look at EIA at that time, they didn't agree. But now they're all agreeing. Now things are looking much better. All the analysis are showing similar trend. So I have more trust. But if you're talking about 5% doesn't change, I don't know. They're not. So somebody can take up all the analysis and compare the change. If they're all agreeing the same level, I would say yes, the good one. If they show a lot of variation, I don't know. Although I would think that if somebody I need people can take actual wind data and on check, right? Somebody should do that because that is actual data. So you don't have to do an every analysis. That should show whether you get when a daily decline and average over the long thing. That should be checked. Yeah, there's another paper. Again, I forgot the name of the paper. They are shown nicely. Now they have done something peculiar. They have got a trend over a long period, 31 to 2050. I don't know why. Why they chose 31, I'm not here. But a long time. So the trend is still clear. Can you see that? The concrete thing you talked about, it is there, it's increased. Okay? So there's something there, but now we have rain somewhere goes back to 1900, right? I don't know whether to trust, I don't know. But it's worth asking whether that analysis shows for this period the same pattern. It's worth asking that question. Okay, now that completes the discussion on Rajendran's contribution, which what I think got him the new job he had got. Now, one question many of you asked about the answer dates. Okay, I thought I'm very skeptical about what is coming here. And the best way to illustrate that is what YP Rao put in his book. He put a dotted line because that is not real data. That is interpolation. Okay. But now they have forgotten that they want solid. You should do that. Okay. If you want people to trust you, I don't know in the book what are you putting? I want to know. Find out. Okay. Because if it's not in actual data, you should draw a dotted line. So the old timers had a very clear logic. So from here to here, they drew that line because there's no data except 4 plants here, 1 point you can take. Rest of there is no real data to go by. Okay? But what I would argue is for some of the students, we have a little more trust with the recent IMS data for the last 20 years. Even daily, I think has somebody can check. If they take the daily data from IMERGE and apply the same criteria adopted by IMD for onset in those grids, do you get the category of line or not? So that somebody can, for 20 years data only, not much. Okay, now come to this year's monsoon, and this is the point I made. From May 26 to June 19, you are sitting there. Okay, they have not moved, very surprising. So this whole region progresses. It should have been here. Somewhere here it should have been. Somewhere near Kanpur. I remember I was in Kanpur for 7 years, waiting for the monsoon to arrive because June first week is horrible. I mean, it's absolutely. I used to run away and come here because June first week is so bad because if it comes late, I mean, it's very heat wave and other problems. So this is what happened this year. By June 19, it should come somewhere here in UP, but it's not progressing. So you'll get a lot of very adverse conditions here. And I'm not getting any discussion about why this is a start. Okay. Now, the typical description of IMD people is this is the so-called westward onset, and this is the eastward one. And they'll say this is start. Okay. But I would argue, yeah, this is going according to date, this part. This part is not going. So my suspicion is in a normal year, there'll be those and other things going across here, which has not happened. Now, I want you to keep this in mind because remember the first discussion we had, there are many models showing Orissa will be below normal this year. So who knows, they may have got it right. We have to see whether it changes in the next few months.
Sir, most increasing is within just 200 kilometers distance. There is a heat like North Bengal is flooding, and just 100 or 200 kilometers below.
Which is flooding?
North Bengal. North Bengal region is flooding.
Yeah, but let me explain to you. That I would argue in terms of the outer phase relationship between this and this.
Yeah.
Okay. When the monsoon is not coming in India, somebody else is gaining credit. Okay. So North is always going out of phase with the rest of India. So that could be the reason. You're right. This part is getting really very heavy. We'll see that I'm sure.
No, I'm just saying the Bengal region, just North Bengal is flooding and just 200 kilometers below there is no rain.
Yeah, but North Bengal is a very small region.
Yeah.
Does it
All
go?
the part of UTC.
Yeah, part of it. And is it orographic mostly?
Probably.
Yeah. See, orographic terrain is just orographic is just need winds. You don't need low pressure system. You don't need anything. You need moist wind. That's all. Okay. So to me, orographic terrain is much more reliable than depending on synoptic systems to rate the parcel. Okay. So I couldn't get today's data, but as of yesterday, all India is 20% below normal. According to this, 59 supply, 50% below normal, which is surprising. This is of course pretty bad. I think this is coming in because they're including a lot of parts of other parts of PR and so on. Central India is minus 30%. That is the core is here generally. And Southern India will enjoy well above normal. That we all know. We can see that right here. Okay, so what is the spectral pattern for the first 18 days of this one? Of course, the mathematics is already there. You can see the monsoon is really stopped here, pretty much. Okay, up to here everything is fine. After that, minus 40, minus 50, minus 30, minus 40, huge thing. And you are right. This portion is above normal. Yeah, and this is above normal. I don't know why this part really bothers me. Two adjacent divisions having totally opposite trends, which doesn't make sense to me. It may change. This is plus 30%, this is minus 20%. So my gut feeling is this is orographic trend, and maybe this is not orographic. I don't know why this is showing a different trend. And anybody knows anything. I don't know much about that area. Okay, so you look at, you can see that the last 1 week has been terrible. Okay. India as a whole has continuously not getting good rainfall. And if you look at the core monsoon zone as defined by IMD, it is even more severe. Okay. This is one standard deviation shown here. It's really terrible. And what's interesting is, according to IMD, you will see now in the next slide, is going to recover. That's the. But other centers don't agree. So this is going to be an interesting issue. What's happening? Okay. So you can see they got it wrong the last week. The last week, this is the forecast. 1 day differences, unfortunately. The forecast, this is the actual data. You can see they thought rain will go to Rajasthan and Maharashtra. It didn't happen. Okay. And it is much worse than what predicted. And this is also wrong last week. So you can see that they were right here, but rest of India, they're up to here, they're okay. But rest of India, they're completely wrong. Now, all India looks, that's the funny part of all India. All India looks okay. So this reminds me of our election exit polls. It was completely wrong in UP, which is shocking because I followed it for 40 years. I like it. I think it's very similar to monsoon predictions. There are a lot of surprises. Okay? So UP was completely wrong. And actually, I looked at it in detail. It was a very interesting phenomena. I don't blame them because the vote percentage of NDA has not changed from 2014 to 2024. But the other votes got combined and they lost 33 seats. So locally, anything can happen. Locally, it's a very complicated phenomena. But all India, although they didn't get the seat correct, they got the vote point correctly, all India. So this typical, I've followed 40 years. except for 2004, most of the time, exit polls correctly predict the who will form the government, but they got the seats wrong. But not as much as this. This year was very bad. And one more thing of this year, if you look at details, people have done analysis. One part of the exit poll is you assume people tell the truth. Sometimes they don't. This is what these guys have to worry about. And how many of you saw one of the exit poll company, the executive cried in TV. Do you know why he cried? Not because he's worried about India not majority. He cried because he loses business. Because remember that India is the only country which has the highest number of exit polls in the world. Anybody can guess why? We are not a rich country, but we are the highest number of exit polls. I didn't know it until recently I found out that we are the largest consumer market, and all these exit poll guys are involved in consumer survey. So to get what do you call any company to call them to do the survey, they have to show that they are good, and exit poll is the best way to show it. So Chanda, if I remember correctly, a couple of years back got the Delhi poll absolutely right. So suddenly their name went up, they made a lot of money. Then the next time they got it wrong. Okay. So these guys are very concerned because they do exit polling. It's very expensive, it's not a cheap thing. They do it because of the money they get from consumer survey predictions. So that's why this guy cried, because he knows it's not good. But exit polling, there's a difference between exit polling or opinion poll for consumer market versus politics. In the consumer poll, I don't think people will tell lies. They don't have to. But I think in the case of political things, sometimes people are not sure, especially when educated urban youth go to village and ask questions. They don't trust you. Okay, let me prove it. That if they want to get the correct this one, they have to send somebody who is local. Because people don't trust outsiders. Understand. When a village, somebody goes outside asks questions, you don't know who is what is up to. So that's what happened this time. And it happened a couple of times before. Okay. So all India getting it right is kind of an accident. It's good so far. So this is what I want to look at. It has gone up according to today. I'm not seeing the dot today. I don't see much. But I think they are saying that I'll show the next forecast. This is even more impressive. Okay. So according to IFC forecast, it will go on. This is very good. If this happens, June will be normal. Because if we won't have 4 millimeters per day above 1, 2, 3, 4, 5, 6 days, okay, you will make up for a lot of deficiency. Yes.
Just a comment, this massive night forecast.
Huh?
This massive night forecast.
Really?
I will check your week. I said 18 June will be there one set.
It will be normal.
No. I didn't say anything about it. I said that 18 June is the forecast on set set.
Okay.
You can check your week.
Almost in the photos,
Right there, but yeah. Even I said it is, I don't even care on onset has happened actually.
Okay.
It is happening now.
Okay.
Because Kerala there is an onset. How can it be? It is monsoon. How can Kerala have below normal rainfall? Entire South India is having rainfall. Apart from Kerala.
Yeah.
You can check on this one.
Oh.
So it is all happening because of water vapor. It's all climate effect. It's not entire day. It's not raining. It's already raining in the season. So entire system. It's not like a monsoon system now. That's what might be.
We'll see what happens. Okay, now I want to compare this with two other things which well known. One is GFS from NSUP, GFS, and this is the ECMWF. Both are identical, and both are showing that monsoon is not going till July 2nd. Monsoon is not going beyond this. Okay. To me, this is a very interesting result. So this goes against IMD's prediction. So these two models are saying, and normally these two agree, normally it's right. These two agree that for whatever reason it's not going further. So if that's the case, June will be below normal. So that is the point. Now let's look at IMD forecast for the same period, a little bit beyond. It's very high rainfall, all these reasons. Okay. So this is not agreeing with ECMWF and GF. So we have to see who's going to get it right. And this part, this is the forecast for the last week and this week. Now, this I think they got it right. This week, we are on 90. Yeah, it has not gone much beyond this here. But I'll check next week. I'll get the data. I'll show you how good it is. Now, this is Nigam's forecast. Someone Nigam has a forecast based only on S&P, which is interesting. He is getting very low rainfall for the winter. Bihar and West Bengal and Northeast and so on. High rainfall over Maharashtra. So Nigam and Rajendran are not agreeing. They are going the opposite direction. Okay. So we will see who will get this right. So last year Nigam was very good till about August. Then September came and completely upset his very accurate. And I want to notice this. Okay. So far Kerala rainfall has been normal because the system not moved beyond. But we have 3 more months to go. So we'll see whether this feature, which we discussed in the beginning, will be there this year. So that is the. Okay, I think that completes the. Yeah, any questions?
Right, they're going to show that India rainfall, right?
Or what? This one?
I think before that.
Huh?
Before that, spatial map. With a spatial map, right?
Yeah.
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 Does it say that it is a below normal in Kerala?
No, this is just 1 week. Minus 10%.
Okay.
Just week, not cumulative. So I'm also going week by week, just to show which week I'm on right. That's all. Okay, so next week it will be Shankar, who John is MTech student here, converted to a PhD. So he's going to talk about March article budget discussion. So that will be next week. Okay, thank you.